Suppose we have an incline given. Suppose we are having an incline given and we have an object on this. So normally what will happen if we have this incline at rest, the object here will start sliding on the smooth incline, and we know that how much is acceleration, that is g sin theta. If this incline is stationary, the object here will slide down with acceleration g sin theta. That we have already done in the previous questions. But if this whole thing, the whole wedge starts accelerating with a naught, then what will happen that we will have a pseudo force acting apart from mg and normal, which generally acts. We will have a pseudo force acting ma naught, and because of the pseudo force, the object may start going upward, because the pseudo force, that will depend on the value of pseudo force actually. If pseudo force is large, then this object may start going upward. So if you apply very large pseudo force, so how will you apply very large pseudo force? If you provide very large acceleration. So if a naught is large, the object may start going upward. The block may start sliding upward. May start sliding up. And if a is small or 0, if a is 0 or small, then object will slide down. Object slides down. Okay. So there will be one value of acceleration so that this object will remain stationary on the block. So we have to find that value. So find value of a naught so that block remains stationary on wedge. Block remains stationary on wedge. Wedge is triangular wedge. Triangular object is called wedge. Okay. So on wedge, the block remains stationary. So these are the three forces. So to remain stationary, the net force has to be balanced. So how do we write the equation now? Forces equation. So we will take this as x and this as y. This is normal force. This is mg and this is ma naught. Here it will be theta, and it will be theta. So along x, if you write equation, along x, the equation along x, will it be mg sin theta down the incline? This component, mg sin theta down the incline. It will be mg sin theta down the incline, and then ma naught cos. See, you can see what will be its component along x. So this will be the component. That is ma naught cos theta. So ma naught cos theta up the incline. So mg sin theta down the incline and ma naught cos theta up the incline. These two must be balanced. So if we balance it, we are going to get g sin theta equal to a naught cos theta, or we can write a naught is g tan theta. So if we accelerate the whole system with this acceleration g tan theta, then this object is neither going to slide up nor going to slide down. Okay, so this is the required acceleration. Now we can also find the normal force exerted on the surface. So for that we need to write y direction equation. Writing y direction equation for finding value of normal. So along y, if we write, so along plus y direction we have normal, and along minus y direction we have mg cos theta component, and then we have ma naught sin theta. This part will be ma naught sin theta. So minus ma naught sin theta. How much? N will be m g cos theta